Hello, class. Today's the last week of April, April 28th. And for today, this week, we're going to wrap up the trigonometric graph, and we will take assessment on this as well. Now that we are talking about the most of the components discussed in trigonometric graphing, now we're soon coming to an end when it comes to these trig graphs, and most likely I'm going to give you a special project to do regarding this. So for these types of questions that we see here, um, we always have been dealing with amplitude, a phase shift, and a vertical shift. And I've given you a test yesterday. I hope you guys have done that well. We've been talking about how to make the framework and how important that is, and it's going to come into really a full picture when we're dealing with frequency. Now, when we're talking about frequency, this will take some time. This entire week, we're going to be just strictly talking about frequency and how to implement it on this graph here. You're going to have to learn a new thing called a new period. And the frequency and the period is basically the hardest part about trigonometric graphing. All of these other things that just comes into the picture. For me personally, I find these to be the most challenging because the amplitude, phase shift, and vertical shift, they all go up and down, and and your x scale has not changed at all. But now your x scale will change because of this, what we call a frequency value and a period value. Okay. Okay, so here what I would like you to do is I would like you to take some notes down. This is the full picture. You don't really need to write down all these steps, but if you want to, you can. But this will always be all the trigonometric functions that you will see for any trig value, any trig graphing that you will see, that you will always see amplitude, period, phase shift, and vertical shift, or you will see an absence of those four components. Okay. So right here, what I want to do here is I want to first go over what period means and how it impacts the graph. So the B value that we're going to be talking about, it represents frequency. Okay, a frequency is how many times does a full cycle happen. That's my own personal definition of it. So in a regular sine cosine graph, you see one right down here, a sine graph, is that a full wave is basically one uphill, that's what I like to call it, one uphill, and one downhill. Okay? A full wave has these components, and this right here is considered a one full wave from 0 to 2 pi. And if you take a look at the unit circle 2, from 0 to 2 pi, well, that creates one full circle, right? And if you extend that on an XY grid, that's what happens. This one full wave happens, not a circle happens. Okay? So you see that in a one full wave, that is also talking about those five essential points that we're talking about: 0, 1, 0, -1, 0. Those 5 points always come together to create one wave, one full wave. So a frequency is how many times does it happen. Okay, so frequency in a 2 pi frame. So for example, if let's say I gave you a sine of x, because the b value is 1, it means that there is one full, that's my fault. There is one full wave happen every 2 pi cycle. If there is sine of 2x, it means that the b value is 2. Okay, what that means is the full cycle happens twice per 2 pi of a frame. So what actually I'm going to show you what that's going to look like is you're going to see a 2 wave, like, and 1, 2, 3, 4, like that. Well, yeah, the amplitude has to be 1, so and the -1. So here you go up, down, and you create this one full wave in a pi frame rather than a 2 pi frame, because it has to happen twice as faster. It has to happen twice as fast. And a period is how long it takes for the graph to have a one complete cycle. So for example, for sine of x, a period would be 2 pi. That's the how long it takes. in an x scale how long it takes for a sine graph to complete its one cycle. Sine of 2x would mean that it happens every pi. Well, because, as you can see, a full cycle happens every pi frame, and that's what it's going to be. So to calculate the value for the new period, this is the formula that I want you to remember and write it down. It happens every 2 pi over b. So if b value was 1, that means that the period is 2 pi. If the b value was 2, that means that the frame would happen, the full wave would happen every pi period. Okay? All right, so let's take a look at some of the examples here. Let's see just y equals cosine of 2 theta. Okay? So how do we plot this? Well, if we're talking about the actual regular graph, we know that the amplitude will happen at positive 1, or I mean like the max value will happen at positive 1. The min value will happen at negative 1, and you know the midline is at 0. And it's going to alternate from the high, max, mid, min, mid, and then max. So this would be your regular, oh, that was bad, right? So this would be your regular cosine of x graph. If I ask you to write down what amplitude is and frequency, well, the amplitude here is 1, and the frequency here is 2. What is the new period for the value above? Well, that's 2 pi over b, which means it's going to happen every pi cycle. Okay, so here's how it's going to work. To graph y equals cosine of 2 theta, I'm going to use blue. So to graph this, what's going to happen is that for every single pi frame, I have to complete one cycle. Okay? And when you're graphing this on a graph paper, I think I have written down for you somewhere here this. When you're drawing these on a separate sheet of paper, you need to memorize this. Make sure that each increment, in other words, your x scale increment, is your new period divided by 4. Now, why do I tell you that? Well, it's because imagine if we've been dealing with this type of graph a long time, this graphing frame. I've always given you 0, 2 pi over 2, pi, 3 pi over 2, and 2 pi. You know why? Because those 5 essential points happens at those according spots. But the reason why I gave you pi over 2 scale is because if the period for cosine of x, let's say, happens to be at 2 pi, a full cycle, if you divide that by 4, it becomes pi over 2. And so every pi over 2, that's the increment that I'm going to set. Like from here to here, that's pi over 2, pi over 2, pi over 2, pi over 2. Because if I were to take my full wave and divide it by 4, I know I can get those exact locations of essential points. That's the whole deal. So if I'm going to take my new graph, which says the full cycle happens every pi period, pi radians, then my scale would be pi divided by 4. That's what I needed to make it. So here, that would be pi over 4. Okay, so it's going to be really tough. And then that's pi over 2. That's 3 pi over 4. That's pi. So it's pretty much halfway through for each of these. And it's going to alternate among those values. So at 0, I'm going to start at 1, that's for sure. But down here at pi over 4, I'm going to go to my mid. Then I go to min, mid, and then max. And you can see how already a full cycle happened right from 0 to pi. When the red graph, I'm going to enlarge this one so you guys can see better. This graph completed one cycle at 2 pi. But I have completed already my one cycle at pi. And then if I do the same trend again, mid, min, mid, and max, there we go. So in a same frame of 2 pi, I have 2 cycles completed, or pi is my new period. So I have 2 full waves. One, and there's 2. So I have 2 full waves instead of having just 1. Okay? Now, what I would like you guys to try is I would like you guys to try some of these other problems here. And notice that I didn't give you any scale for this, like the x scale, is because I want you guys to make it on your own, because it depends on whether the period could be 2 or the period could be 4. I mean, the frequency could be 4 or the frequency could be 2. So your new period is subject to change every single time. Pause the video now and try this question on your own. And make sure you identify the amplitude, new period, frequency, and each increment. This, I cannot emphasize enough how important that is. Remember, each increment is the new period divided by 4. Okay, pause the video and try this on your own. Or you could just start the video already. Actually, I'm going to start it right now if you guys are just ready to see it. So 2 sine of 2x, okay, so now I want to make sure the amplitude is 2, my frequency here is 2, my new period will be 2 pi divided by b value, which means it's 2 pi divided by 2, which means it's pi. That makes each increment to be pi over 4, and that would be 45 degrees. But I don't want to use degrees, I want to use radians. So first my job is to establish the framework. Always establish my framework. So there is no vertical shift, so I know that it happens, the midline happens at 0, and you won't see any vertical shift for today's homework. Amplitude is positive 2, negative 2, those are my max and min, so I established my framework, okay? Now, if you guys want to draw the original graph, so let's say I draw the original graph of 2 sine of x, versus in blue, I'm going to write 2 sine of 2x just to show you the differences. We all know how to graph this, right? We can make this to be a pi over 2's frame, so I can make this, I'll actually use black to make it better. Pi over 2, pi, 3 pi over 2, and then 2 pi. And then what's going to happen here is that my original graph in red, it's going to alternate from 0, max, 0, min, and then 0. So I'll have my one complete cycle like that. Now what happens here then is my new graph, which is 2 sine of 2x, my new increment is now pi over 4s. This would be 5 pi over 4, 7 pi over 4. So I am going to make sure that my alternation between my mid, my max, and my min happens every pi over 4 framework. So if I zoom in here, my starting point is the same, but my max reaches at pi over 4 because that's my new increment. Then it reaches middle line at pi over 2. Then at 3 pi over 4 it reaches min and it goes back to mid. And what you notice is that a one complete cycle happens every pi period. Then another thing is going to happen, another wave is going to happen. Ooh. Hello? Okay, alright, thank you. Can I just call you back? Thank you. Okay, sorry about that. That's really real. So then it's gonna reach another of one full cycle here, and then that's going to be 2 cycles in total. And that is just going to be my first half of the frame. Obviously, for the next half, like this part, you can do it on your own if you wanted to give it a shot. And that's going to be it. So 2 sine of 2x, you'll graph it like this. And remember that the new period always impacts how fast or how slow the wave is going to be. Eventually, what I'm going to show you here to do is versus, let's say, 2 sine of 1/2 x and see how that's going to impact the graph. That means it's going to happen twice as slow. So you will see a different types of waves in those regards. So the biggest thing that impacts the graph here is going to be your period. You will see that as the time goes by. Okay. Hope this video helped. You will have 2 questions to do for homework, and that's going to be it for today. Thank you, and have a great day.